Okay, Assalamualaikum. For the case study of static load test, the purpose of a pile is to transport a structural load into the ground without the risk of shear collapse or excessive settlement. End bearing piles and friction piles are the two most common types of pile. Okay, one approach for measuring a pile's load carrying capacity is to do static load test only. It can be done on a driven pile or cast on a working pile or test pile, on a single pile or a group piles. Okay. For static pile load test, they were specified in the tender plans for all structures with deep foundations in accordance with conventional design practice for the finalization of the foundation design. The most significant aspects of the proposed pile load test program was that a static or dynamic pile load test should be performed on all structure where an in-situ test was initially required. Okay, for the objective of this study is, first objective is to compare the settlement of every model. Okay, the second is to compare the result of settlement and excess water pressure.
So, for the proposed model, there are numerous analyses for various soil condition and piles that are possible to be used in numerical modeling. So, the piles will undergo the loading and unloading stage where several loads is applied on pile to evaluate and identify the load settlement behavior. So, these are the information, pile information that are obtained from previous research from BAK 2013. Okay, let's move on to the geometry model, where the model consists of three materials such as soil, pile, and rock. So there are three types of constitutive model used for soil materials, includes small column model, MC model, hardening soil model with small strain stiffness, HSS model, and also soft soil model. So these three constitutive model are used for soil material, while another rock and piles are used constant consistency model. So this soil test was simulated under axisymmetry condition with 50 noded elements, and the contour of model x minimum with 0 meter, x maximum 5 meter, y minimum 0 meter, and y maximum 15 meter. So this is the model that will be simulated in the Praxis 2D software. Okay, so for the first model, which is MC model, monocolor model, why we choose this model? Because of this is a model that most often use consistency model for porous media, and also it is useful for simple stress path and provides a linear, elastic, perfectly plastic prediction for soil behavior. And it is also straightforward and estimate a constant average stiffness. It is also fast computation due to constant thickness and will provide relatively accurate result for soil. So these are the parameters that will be substituted in the Praxis 2D. Okay, so for the second model, which is soft soil model, SS model, it is chosen because of it can count both elastic and plastic material behavior compared to MC model. It is also advanced model with failure behavior based on MC criteria, but it is not suitable for other types of soil than soft soil. So it is also better capable to model the compression behavior of very soft soil. So these are the parameters for soft soil model. Okay, let's move on to the last constitutive model, which is hardening soil model with small strain stiffness, HSS model. So it is chosen because of it can count for increased soil stiffness at small strains, and it can evaluate variation of shear modulus regarding the small strain condition. And it is also advanced features of HS model that are most apparent in the working load condition. This model also provide more accurate displacement than MC model, and the result of the computation times that are significantly longer than the HS model.
Explaining about the methodology. So for the first one, we need to define the project property. In this project, the type of model and element used are axis symmetry and 15 noded. The size of draw area can be set in the contour which contain of model dimension, which are x minimum, x maximum, y minimum and also y maximum. Stage is known as soil stage. So the material can be choosing in global material section, where this is common types of material that available in the real life condition. So there are three types of material that have been chosen, which are pile, rock and also soil. The material model can be changed based on the existing constitutive model such as small column, soft soil model and also hardening soil with small strain model. The second stage is structure. So the borehole for pile load static test can be created using the polygon. So the dimension of the borehole is determined and set based on the project specification for pile static load test. Moreover, the loading can be created by using the load icon, which known as assign the load line load. The third stage is meshing. Mesh generation takes full account of the position of points and lines in the model, so that the exact position of the layer, load and also structure is accounted for in the finite element model. There are variety of mesh size or element distribution in the Paxis 2D, which are very coarse, medium, fine and very fine. For the model of the pile load static test, the mesh distribution is used as medium. For the flow condition, there are types of boundary need to be determined. There are four types of boundary, which are boundary x minimum, x maximum, y minimum and also y maximum. The boundary condition can be defined either open or closed for every axis. Moreover, the groundwater level is located at 0 meter below the ground surface. The last stage is known as trace construction. So for project has been defined at first calculation phase named as initial phase. So the initial phase condition comprise the initial geometry configuration and initial stress state such as effective stress, pore pressure and also other parameters. The pile construction phase is created and continue with the loading and unloading phases.
Present about the results and discussion in this project. The result of numerical model using Paxis 2D for more column, soft soil and hardening soil model as shown in Table 1, Table 2 and Table 3. The pile diameter, pile surface area and pile loading are constant variable in all three models. As seen in the table below, the maximum soil settlement in millimeter and the maximum loading is highlighted. The modified parameter for the three models are total soil load and Q, which relates to the distributed soil load. The table 1 shows the settlement for more column model, table 2 shows the settlement of soil model and table 3 shows the settlement of hardening soil model. Table 4 shows the comparison of settlement data for three different numerical models. From table 4, the increase in soil settlement coincides with the increase in soil loading. However, the settling value for each model type differs based on the soil characteristic used. The hardening soil model with little strain stiffness has the smallest soil settlement, while both the hardening soil model and soft soil yield at 1200 kiloliter. The soft soil settlement is greater at 15.38 mm than the hardening soil model, which is 10.69 mm. Unlike soft soil, which is very elastic and flexible, hardening soil model has a low strain stiffness, which enhancing soil stiffness. This graph shows load versus settlement for three types of model, which shows the variance in finding between three models. The hardening soil model and more column model settle similarly compared to the soft soil type for each loading and unloading. However, after unloading, the hardening soil model settlement reduction value is less than the more column model. The more column is best for simple stress channel and predicts linear elastic completely plastic soil behavior, whereas the hardening soil model is best for soil behavior. After considering for the result with three types of model, it is possible to conclude that hardening soil with small strain stiffness is the most efficient and suitable soil to utilize in the static load test pile.
For the conclusion, numerical analysis model was conducted to analyze the difference in soil settlement between three proposed constitutive models, which is mock column, soft soil, and hardening soil using Plexi 2D software. According to the result that obtained, the results show the rise in settlement of soil occur simultaneously with the increase in the amount of loading imposed on soil. The overall result can be concluded that hardening soil with small strain stiffness is the most efficient and suitable soil to utilize in the static load test PI. Hardening soil model has a significantly lower soil settlement rate when compared to the other two models, which is a result of higher soil stiffness at small strain. For recommendation, there should be in-depth understanding on the concept, advantage, limitation, and also output of each model for each problem being modeled. Engineers should also make use of constitutive model which provide a reasonable fit to data obtained from range of laboratory tests. It is important to conduct various computation measurement comparisons along with additional full-scale experiments to make it more accurate in choosing constitutive models.